Then, after knowing the direction of our sun, the angle of our sun, and the climate zone we are in, and we have acquired our design weather file, now we can go to the construction of the walls, the roof, and then the floor, and the windows as well. But you don't just do it randomly. That's when we use ASHRAE 90. ASHRAE 90.1 is normally used for buildings which are like more than 3 stories and above. It's that there's not much difference. I mean, residential buildings are more than 3 stories and above, and also commercial buildings. For residential buildings with only one story, 1 to 3 stories, these small buildings, we use ASHRAE 90.2. They're almost the same, but there's some differences which we will notice if you get a closer look into it. Yeah, but let's design according to what we have here. This in this case, I just want to actually 90.1 is the only one which I have near me. I think I'm kind of I use this regularly more than I use actually 90.2 because so I don't have actually 90.2 with me right now. But see, for just for the sake of learning, let's just use this. So as you can see, we have residential area, since it's a residential area, roof. Want to use a roof here. Our roof should have, if it is insulation entirely above deck, is to have 0.273. Attic or other to use 0.153. So let's use yeah, since it will be insulated above the deck, I mean, let's use this. But okay, in this case, the attic, we have to insulate the attic, not insulating the roof as it is. So let's use the attic and other 0.153. So you come here to IES, you go to construction, Apache construction database. You come to Apache, then you come Apache construction database manager, you open, and then down here, you look for the roof. Here you got it. There's one roof already assigned, and just copy it. I mean, just make a duplicate and then edit construction. Right now, this is a U value of 0.18, and we want a U value of 0.153. So 153 and 18, it's not that much different. So control so that you reach your desired U value, the term of property we want. You can just add this to 155. You see that this goes down. So if you use insulation of 160 millimeters, normally they come in 150. For you to reach 160, you have to cut it, but it's not recommended. So let's just use 200. It comes down to 0.141, which is a little bit near 0.15, which is okay. So it means your roof is okay at 0.141, but we have to, yeah, see, there's the U value. We want 0.153, so this one's closer. Okay, and then we come to the walls. The walls is mass, since we're using bricks and stuff, 0.592. You come here to the external wall. Let's copy this and let's rename it. Let's rename it like energy efficient, then energy building 3A for climate zone. And then let's edit that using our materials which we are going to use on our construction. We're not going to use any metal. So I can delete it. We want to have a brick wall, let's say a double brick wall. So you come here to system materials, brick and block outer leaf. Then you copy this material, copy it, and then you come here and you add. It comes with the wrong, so you can flip it. So our thickness, let's just use a thickness of like 230 millimeters. Our wall of 330. And then from there, we want our insulation, not this one. Let's remove this. After that, we put a membrane that you may choose not to include it. Yeah. So we might put a membrane, but let's go straight to insulation. We want to use mineral wool. It's quite good. Mineral fibers, mineral wool or wool. I'm using it. Okay, let's just use glass wool. Let's use glass wool. You do the same thing. You copy, and here you insert. It's just going to. Okay, don't put it here. Insert here. Yeah, now it's now in the right place. After the glass wool, we can have the plasterboard on top. As we want it. So between the brick wall and glass wool, we can have a cavity so that we can have free air circulation between the brick and the glass wool, so that you won't have a problem of water vapor not having time or having not concentrating beyond the brick. So you need free air circulation so that moisture from outside can just come and then go back. So that's why I was saying you need a membrane so that moisture won't enter, or you won't create cold drafts, which caused a lot of moisture problems in houses. So the cavity, we have 0.9, want to reach 0.9. So you increase your insulation. Normally 50, sometimes for climate 3A, it's okay. As you can see, it's 0.5 already. So 50 is okay. Yes, you start. And you have to assign this. What else? We've made the wall. Then the walls above grade is on the floors now. I want them mass. So it should be, you are not using wood. We are using like the mass, the concrete mass. We need that thermal mass which stores it. So as you can see, the floor should be 0.496. That's almost 0.5. So you come here, you come to the floor. You can see the floor is ground exposed floor. Yeah. You click it, you see then you copy. You edit the one you have copied. It's 0.2, and we don't want that. We want something, yeah. So it's like chipboard. We start we start from the outside to inside. So you can you can reduce this to 50. The insulation, depends the insulation which you want to use. They're using visual. Anyway, let's remove this. And let's use the cavity to 20. And we want 0.4. 0.496. 0.3. Yeah, now it's 0.5. I think it's okay now. We can rename it to energy efficient building 3A for climate. Roof as well. We can rename this efficient energy building 3A. So, oh, we didn't specify our windows. Windows and doors, these are all doors 0.9, 4.8. Glazing 0 to 40% ratio. That's what I was saying about the glasses. The more the glasses, it means you create a lot of the more bridges, but we should have windows with 3.69 with metal framing 3.69, and doors should have 3.957. So you come to glazing, you see external window. Let's rename it to EE building 3A, and let's edit the window. It's 1.67 and we want it to be like around 3. So the windows, they work differently. What is most important about the window is the transmittance. Transmittance, which means how much energy is allowed to transmit through, like the sun energy when it goes through, how much of it we sometimes we may need more in winter so that we can heat up our rooms. So this is a subject for another day. For today, let's just use what we have. This double glazing, let's just use this. But you should reduce it to 3 point something. How you do that? It's you just go to single glazing. If you just remove double glazing, it goes to that. You just okay. Let me put another glazing on the inner one. Let's use double glazing. Inner pane, copy instead. Yes, now it's now 3.16. That's exactly what we want. But let's make them to be 6 mils both of them. Let's make them 13. The thicker it becomes, means it won't allow a lot of heat to come through. So we can make the other one bigger and bigger than the inside here, like this. Which one